I was hanging with you and then I realized I didn't think it was true.
Hello everyone, good morning. Today we are going to discuss about green chemistry. Before starting the discussion this time, allow me to introduce myself. My name is Nadya Kartika Putri, along with my two friends.
Hi, my name is Hana Yusriyah.
My name is Faruk Nur Pratama.
So, what is green chemistry? Well, this definition comes from the Environmental Protection Agency. Green chemistry is the design of chemical products and process that reduce or eliminate generation of hazardous substances.
Okay, from Nadya, I want to continue the material that Nadya described. So, overall, essential green chemistry is the idea of making chemistry more environmentally friendly as well as more sustainable.
Okay, thank you Hana and Nadya. Then I will tell you about the history of green chemistry. History of green chemistry. In early 1900, chemistry was changing from just theory that scientists work on in labs to industry done in factories. This includes making electricity and power plant and making fuel for car. But in mid-1900, negative effects of chemical pollution were becoming apparent. Around this time, many countries around the world began forming groups within their government to combat pollution. In 1970, America formed the Environmental Protection Agency. In 1990, the Pollution Prevention Act was passed furthering America's policy for green chemistry. However, green chemistry is always attempting to take further steps in its goal. There are 12 main principles of green chemistry. Number 1. Prevent one-decision reaction that leveless was or not allowed. For example, one of the winners of a 2012 presidential green chemistry challenge was a professor that created a new reaction to create Synfusions, a cholesterol medication that uses less step and raised the yield from its blood pressure from 70% to 97%. Number 2. Maximize atom economy. This means to create reaction whereas many of the starting material as the natural product as possible rather than unwanted extra products. This helps fit into preventing waste. Atom economy is calculated by dividing the weight of the product by the weight of the reactant. Number 3. Design less hazardous chemical synthesis. Design reaction that use to produce as few harmful chemicals as possible. Number 4. Design safer chemical and product. Design chemical that can perform the same action as those that access but less toxicity. For example, procuring and well-development a mixture of For example, Number 3. Design less hazardous chemical synthesis. Design reaction that use and produce as few harmful chemicals as possible. Number 4. Design safer chemical and product. Design chemical that can perform same action as those that exist but less toxicity. For example, procuring and well-developed a mixture used in kind that use soya oil and sugar rather than fossil fuel, reducing the hazardous component of the pan 15%. For the next principle, can you explain?
Okay, thank you Faruk. The next principle is use safer chemicals and products. Avoid using toxic chemicals whenever possible. This is similar to number 4, but it's more about the use of chemicals rather than creating new chemicals. For example, in 2014, QD fission in developed away as Hagas UV hydrocarbons, and a reaction that is previously used for more hazardous materials for the creation of flat screen display for phones and TV. The next principle is use renewable feedstock. Feedstock is the starting material that is used for many reactions. So this means to use certain material from renewable resources rather than limit one like fossil fuels. For example, in 2012, bioamber created a method to create systematic acid, an important starting material in many reactions, from fermented glucose rather than from petroleum, which is what is traditionally. Okay, the next principle is avoid using chemical derivative. Avoid using blocking group or protecting group whenever possible, as it generates additional weight. An example of this is terbutyl oxycarbonyl protecting group, also called PUC, which is used as a protecting group on amino acid during reaction.
Thanks for Nadya. The next is number 9. To explain, use catalyst, not stoichiometry regions. So, in principle, catalysts are not consumed, meaning they can be regenerated or reused within the reaction. For example, catalyst pyrobisoxidation is much faster than aerobic oxidation without catalyst. So, which is like oxidation using oxygen in the air, which is normal, but it's very slow because using catalyst. Okay, the next is number 10. To explain design chemicals and products that degrade after use. So in this one, develop products that will naturally degrade in the environment rather than remain cause more pollution. For example, in the OTM eco product. What the meaning is, so this is a biodegradable alternative to plastic called created by the company NatureWorks. Next, number 11 is analyze in real time to prevent pollution. It means monitor our reaction to ensure they are creating as few unwanted byproducts as possible. Okay, one example of this is real-time IR monitoring, as its name would suggest. Real-time IR monitoring allows you to monitor the reaction as it goes on rather than just at the end. The last one, number 12, is minimize potential for accident. What the meaning? So design chemical and reaction that have the smallest possible risks for accidents, and to practice lab safety to prevent spills or other harmful accidents. For example, this helps prevent damage to the environment, the lab, and you. So it means minimize potential for accident. This includes both design chemical and reaction that have the smallest possible risks for accident, and practicing general lab safety. This prevent damage to the environment, to the lab. Okay, from that we can be carefully to minimize potential for accident. Okay guys, that will be all for our presentation. I hope all of you happy to hear our videos presentation. Thank you for watching our videos, and bye.
I didn't want to believe that I could lose you if I told you just how I felt, but I can't help it. I'm falling for you, and I can't quit it, 'cause I'm stuck on you, and in might be pathetic and you might be skeptical, but I just want to be with you.